Welcome to my channel. Want to see how to determine if vectors are linearly dependent or linearly independent using determinants. So that's what I want us to look at in this video. So supposing I'm given a set of vectors, what we'll be doing is that we'll be extracting matrices out of extracting the coefficients of those vectors and then writing them as determinants. Now writing them as matrices. Then after which we obtain the determinant of the matrix formed. So that's why I'm saying that given a set of vectors, let the matrix formed by the vectors be matrix A. Now if we obtain matrix A from those vectors, then when do we say that the vectors are linearly dependent? We say that the vectors are linearly dependent if the determinant of that matrix A is 0. But if the matrix gives us non-zero determinants, then the vectors will be linearly independent. So I just want to use an example to make this one clear to us. So the example that we have is that of these vectors u, v, and w. The question is, are they linearly independent? So what I do, I form a matrix using these vectors, and the matrix that I form will be my first. This is my first vector, so I make it my first column. My second vector, I make it my second column. My third vector, I make it my third column. And then I want to obtain the determinant of this matrix. There are various ways of obtaining determinant of matrices, but I'll show you the easier one. I'll use the easier one, and my assumption is that you know how to get determinant of matrices. So what you can see here, since these are 3 by 3 matrix, I have my first, the matrix is here, 1, 2, 3, 2, 3, 7, 3, 5, 6. Then I've taken these 2 first columns and added them here. You can see that here, the first 2 columns. So I have this diagonal. The diagonals in red, is it red or pink? These diagonals here. So I'll multiply along these diagonals in pink and add the results. And then multiply along these diagonals in blue and also add the result. So I'll subtract the second result from the first result. So let me see, that's what I did. So I'm getting the determinant. That's how I'll be getting the determinant for 3 by 3 matrix. So 1 times 3 times 6 gives me 18. 2 times 5 times 3 gives me 30. 3 times 2 times 7 gave me 42. And then what about 2 times 2 times 6? That gives me 24. So I subtract 24. Then this will be 35, which I also subtract, and this will be 27, which I also subtract. So the determinant of this matrix is 4. It's non-zero, and therefore the vectors given to us are linearly independent, because we say that if the determinant is non-zero, then the vectors will be linearly independent. So let's look at another example. Okay, I have this set. I have the set, this set comprising of this vector, this other vector, and this other vector. The question is it linearly independent? So I extract my matrix from this. I have the first column, the second column, and then the third column. And then this matrix is here. Then I add the first two columns here beside this. Then I draw my diagonals. I multiply along this diagonal, get 4. Along this diagonal, get -4. Along this diagonal, I have 0. So I've added those 3. Now I subtract this. Along this diagonal, I have 0, so I subtract 0. Along this diagonal, I have 2, so I subtract 2. It's this. And then I began from A because this was giving -2. So -2 subtracted from here will give me +2. And this other one is the one that was giving me +2. So when I subtracted, I was getting -2 here. And then this other one was giving me 0. So in other words, the determinant of this matrix is 0. Since this matrix has determinant 0, we say that the vectors are linearly dependent. So that is how we tell if vectors are linearly dependent or independent using determinant of matrices.